Dear Professor Levard, thank you for the invitation to present at the EBC 2021 meeting. The title of my talk is MicroCT Analyses of Stenting Performed within Reanimated and Fixed Human Hearts. You can see one of those reanimated hearts on the video on the left. EBC members performing stenting procedures within the Visible Heart Lab. And then the lab is located in the basement of the Mayo building. A lot of history of this building. It's the place where some of the first open heart surgeries were performed anywhere in the world. And in the labs themselves is the place where Earl Bakken, the founder of Medtronic, brought the first wearable pacemaker and did a preclinical study back in 1958. So we do really translational systems physiology in the lab, large variety of different studies, but the heart of the lab is the Visible Heart Project itself. We started in fall of 1996, 25 years ago, and this was a collaboration we started with Medtronic back in that period of time. We've had the unique privilege in the lab to reanimate human hearts. Since 2000, we've reanimated 91 human hearts, the last one several weeks ago. So in the video here, you can see the heart is brought into the lab. We'll cannulate it, and basically it's all reanimated with a clear perfusate. So the cardioplegic buffer is flushed out. We'll deliver a shock. These hearts will go into a native sinus rhythm for some 5 to 7 hours. And for the first 2 hours of these reanimations, we dedicated to multimodal imaging to really collect all this amazing functional anatomy and then put this on the Free Access website. After the collection of this anatomy, basically the grad students who are doing studies on reanimated swine hearts can do work on reanimated human hearts, making their work translational. And then after that, we're doing a lot of device placements within these reanimated human hearts, including various stenting and TAVR procedures. These hearts are all preserved, as are hearts that come to the lab that we can't reanimate. And we're using an apparatus put together by Emma Shimstock, one of the current PhD students in the lab, where you can do differential pressure loading within the heart, and you're using formalin, and it'll fix these hearts at an end-diastolic shape and keeping the chambers, aorta, arteries, all patent while closing the valves. These specimens then can be used for a variety of different studies. They can just be, used for MRI imaging, CT imaging, MicroCT imaging, or just study visually with, in your own eyes and have a privilege to hold them in your hands. So here's one of the studies where we took one of these fixed hearts and did a stenting study in it. So we set up the lab, we can do multimodal imaging here. We can look at direct visualizations of the stenting being performed. We can see the ostia of the left main there where the stent is being deployed using fluoro and OCT and watching each step of the procedure. The hearts then are brought over to a MicroCT scanner. This is a X5000 Northstar instrument scanner over in Geological Sciences, which is the other side of the University of Minnesota campus. So here's Tommy Valenzuela, or Dr. Valenzuela. He just finished his PhD a few months ago in the lab, performing one of these studies in the scanner. This was a bifurcation stent, 2-stent, looks like a culotte procedure. And then you're using the right energies and intensities, and you're getting down to 10 to 20 micron resolution. You can then take those DICOM files, put them into imaging software, using materialized mimic software, and make computational models. So we've used both reanimated hearts and perfusion fixed hearts for a variety of studies as well. So in this study, we looked at left main provisional stenting. We used 7 human hearts, and basically on the left video, you can see a procedure done on a reanimated heart, and the one on the right is a procedure performed in a fixed human heart. And again, all these hearts are taken afterwards and used for MicroCT studies. Or you can do this step by step. And in this study, we did a step-by-step culotte bifurcation technique using EBC guidelines. And part of the steps, we had EBC members performing these. And so one step, we just wired it. Then we deployed the first stent. Then we did a final pot. And then we put in the second stent. And you can see in the lower image below the reconstructions of all the models from the MicroCT. Good. We've also performed Posthaver PCI in the lab. We had Dr. Brazoda and Lawson's in the lab when we did one of these. And so basically we've got key opinion leaders coming to the lab. You're getting direct visualizations of the process. We'll fix these hearts afterwards. MicroCTM, make the computational models. We can 3D print these, do fly-through videos like this using Unity software, or you can then put these on the Atlas website. The Atlas website is a free access website. There's over 5,000 videos and stills on there. And again, it's free access because we're gifting all this knowledge back to honor the gifts we got of these human hearts. So if you went to the device tutorial, looked up stenting, you'd see many of the videos performed in the lab relative to bifurcation stenting. You can also see some of these videos on the bifurcation exploration site that Medtronic hosts. Thank you very much.